Hello again. Today we are going to move on to a new unit, and the unit is called Trigonometry. And we are going to basically use trigonometry to solve problems, and it is in fact one of those concepts in mathematics that has been used the most in our society. The root is a Greek root. It's trigonon. It's two parts to that word, trigonometry. It's trigonon, that means triangle, and then metron means measure. So basically, trigonometry is the study of relationship between the sides of a triangle. So if I have this triangle ABC here, the relationship between the sides ABC, the sides, and the interior angle of that right angle triangle, or triangles. Now in this case I have a right angle triangle, but trigonometry also works when you don't have a right angle triangle, but we will deal with that a little bit later on. A little bit of a background history on this. Basically, it was developed between 200 and 380 in Greece. A lot of ancient philosophers and mathematicians, they went through and they developed that, and they use it mostly for geometry, to study geometry and astronomy. But the earlier part of that was that they were using it to calculate or to determine the chord, or a chord measure in a circle. Mostly in terms of the computational piece of that, mathematicians from India, the same timeline, they came up with the most earliest of the known table of values for trig ratios, which we're going to talk about that a little bit later on. You know what that is. All right. So first, I drew a right angle triangle, and the reason it's a right angle because I made sure that there is a little box at the corner here. All right. And this triangle is ABC, and the length of each side, there are small letter b opposite of this angle B, or the vertex B. These corners are called the vertex or vertices. And AB, the longest side in a right angle triangle, is called the hypotenuse, but the other two sides are just regular legs of a triangle. Okay, regular legs of a triangle. So based on that, we're going to go ahead and start looking at the very first ratio, trig ratio, and how the sides of a triangle related to its interior angle. First, we need to label this triangle based on the view of an angle, based on the referencing of the angles. That means that we need to choose an angle. Let's choose this angle A right here. This is the angle A we're going to choose, and based on this angle right here, hypotenuse always stay hypotenuse, the longest side, but the exact opposite side to that angle, reference to that angle, so we start with angle A, that is called the hypotenuse, the opposite side. Okay, simple as that. Next, the side that is beside, that's a funny thing to say, but beside angle B, so the AC, or the side small letter b, this is called the adjacent side. Okay, so that's what it's called. Now that we know how to basically label the opposite, adjacent, and hypotenuse side in a right angle triangle based on, so referencing to a specific angle, we're going to look at this angle, and this angle now looking out opposite, that's opposite side. AB will be the BC will be the opposite side, or the small letter a will be opposite side to angle A. B will be the adjacent side to angle A, and hypotenuse always stays hypotenuse. Okay, so first ratio, and it's called the tangent ratio. Here we go. And basically, first we have to make sure that angle A is an acute angle. That means less than 90 degrees, and it is in a right angle triangle. That's the first assumption that you must have. The next thing is that what is tangent of angle A? And tangent of angle A is the length of the opposite side, so side opposite to the angle A, divided by the side adjacent. And from this point on, we don't actually write the length, we just say opposite over, we say opposite OPP divided by ADJ. Okay, and basically that's what that is, and that's the ratio you get. And ratio, that means a number over another number depending on the length of the sides. That's basically it. Great, let's look at an example. Suppose I give you this triangle, and notice that I changed the vertices, the labeling of the vertices, because I want to make sure that you don't get used to ABC in one form only. So it doesn't matter where the vertices are and what the names are, as long as you follow the rule with the ratio. So tangent is always opposite to that specific angle you're looking at, divided by opposite side divided by the adjacent side. So angle C we are looking at. So this is angle C. So first we have to look at angle C, so which is right here. That's the angle C, that's the corner, that's the angle. So first, what is the opposite side? Well, the opposite side is 2. What is the adjacent side? So you can write down OPP right beside it. And then 5 is the adjacent side. Great. So that's the adjacent side. That's the opposite side. Let's write up the ratio. So we want to know what the tangent of C is. So that would be 2 divided by 5. Simple as that. That is it. Nothing else. All right, let's look at example 2. The second example. This time same triangle. Let's put 2 in here and 5 there, but this time we want the tangent of angle A ratio. What is that? Well, first we have to go ahead again and we have to label what is the opposite side to angle A. That is now the 5 is the opposite side, 2 is the adjacent side. Okay, so again, it matters depending on what angle you're looking at, so the ratio can change. Okay, it's relative, so make sure that you pay attention to that. So angle A, opposite is 5, adjacent is 2, and you're dividing 5 divided by 2. Now if you really want to, that's 2.5, but you can leave it as 5 over 2. Okay, that's it.